Spacesuits are made of many different materials, elements, and functioning mechanisms for them to protect you in the vacuum of space. Good thing. The freezing temperatures and lack of oxygen aren't suitable for any living being to float around without any sort of protection on, not to mention the burning sun rays and potential objects that can crash into you. The technical term for a spacesuit is extravehicular mobility units, and they're extremely durable and expensive to make, with each suit costing up to $10.4 million to make. Each spacesuit is custom-made, with each part and component created and manufactured by 80 different companies. The size of each piece may vary, so it can either fit in the palm of your hand or be as large as 30 inches. The suit has 18 separate items and 16 layers covering it. Well, in reality, there are 14, but if the 2 internal layers are added, it will be 16 in total, so there. Spacesuits have evolved over the decades to be the design it is today, a mini spaceship in human form. It's built to mimic the living conditions of Earth's atmosphere, so that the astronauts can't be exposed to space. It has a system to support oxygen and expel carbon dioxide. It's durable enough to protect the astronauts from solar radiation, harsh sunlight, and little micrometeoroids. The conditions inside our atmosphere can be extremely tough, which is why it has internal temperature control for the bodies and a pressurized enclosure. The temperatures outside the suit can be as hot as 250 degrees Fahrenheit, ouch, to minus 250 degrees. Brrr. It's designed to support life or anyone outside our atmosphere. The main piece of the suit is a cooling garment made out of nylon, stretchy spandex fibers, and liquid tubes. It's delicately designed to fit around 300 feet of tubes woven tightly together in clothing that occupies the whole body, except the head, feet, and hands. It uses chilled water to flow through the many tubes near the skin to regulate the body temperature and cool it down while spacewalking. Think of it like a fan in a laptop that's made to cool it down when it overheats. The whole garment is attached to the life support system. Now, the life support system is one of the most important pieces of the suit and requires meticulous effort to put together. Everything in this compartment is important to keep the astronaut alive in space. Any miscalculation can be devastating and even life-threatening. It houses the pressurized oxygen tanks when they're filled and sealed tight. The oxygen tank can provide up to 7 hours of fresh air to breathe. There's also a secondary tank that adds around 30 minutes of breathing time. Astronauts can't afford to waste oxygen all the time while wearing the suit, so it's important that they strategically allocate those breaths. There's also the carbon dioxide removal device, which includes a filter canister made of lithium hydroxide that's also attached to a tube. That way, there won't be any toxic carbon dioxide circulating inside of the headpiece, and it will always purify the air inside. Next to it is a ventilation fan to cool the astronaut when moving. Wearing a heavy suit isn't easy and requires a lot of physical effort to move. Even though gravity is weaker up there, you still have to move your arms and legs, which can be tiresome over time. There's also a source of electrical power and a two-way radio to communicate with the base. And just in case something happens, a warning system is installed to warn the astronaut of failures in the system. Uh-oh. Finally, there's the water cooling equipment to keep the body cool and regulated. After the life support system is put together, it's attached to the hard upper torso part. The helmet on spacesuits, built for spacewalks, serves as a pressure bubble and is made of strong plastic to keep the pressure of the suit contained. There's a neck ring to keep it airlocked in place and a ventilation system to provide oxygen to the astronaut. And there's also a connection to a backup oxygen tank, just in case. While the astronauts are working in space, they might crave a little bit of water or something. Good thing there's a built-in straw for them to drink from. And also, while working in open space, there's that annoying sun that shines into your eyes. A visor is installed to protect the astronaut from the sun that's made of a gold coating. And what's a spacesuit helmet without a camera to record everything? Since the two-way radio is connected to the life support system, the headphones and microphone are placed in the chin strap where the astronaut can communicate with the base. Space can be dark at times, most of the time. So there's an inbuilt light bar used when operating on close-up objects. Continuing our Space Fashion Show gala, over at the lower torso unit, we have the pants and boots area. There's also a knee to ankle and waist connection, comprising of a pressure bladder and a specially coated nylon. Most of it is made out of different elements and materials to keep it usable and durable in space missions, as well as providing stylish evening wear for that astronaut who goes out at night. You can adjust the size of the rings of the thigh and leg sections whenever you want. This is good when the astronaut is walking and needs to feel relaxed at certain times. The astronaut also wears thermal socks under the hiking-style boots, which have a heat retention system built in to keep those tootsies warm and cozy. The upper torso is hard yet lightweight. It's made out of metal and fiberglass, connecting the inside of the suit to the life support system. It resembles a t-shirt but attaches to the arm assembly, which stretches to the arms up over the wrist. There's also a special connection to the helmet ring piece. Over here, you can find water reservoir tanks, oxygen cans, and much other technical stuff needed for outer space. The newer spacesuits have a hatch in the back for the astronauts to climb in and enter the suit. How stylish! A control module in the chest area allows the astronaut to check up on the external conditions and monitor the fluids and electricity. The gloves are sturdy enough to protect the astronauts when touching and picking up objects while working outside the space station. They're built so well that they can move each finger with ease. They're the part of the body that gets cold fast in space, so the gloves have a heater system to keep them warm. The process of creating a spacesuit requires so many steps and details, so it's not like sewing together a sweater. It starts with a design integration and then modeling. That way, they can see what it looks like without gathering the materials to build it. And once the design is confirmed, they begin gathering all the materials, which can take some time. And when everything is gathered, they begin the fabrication and building, which can also take time. A total of 7 different parts will be created and shipped to NASA for assembly. When an astronaut goes outside the International Space Station, they must have a safety strap attached to them that connects to the station. That way, they won't float away while doing some maintenance work. The longest spacewalk lasted a total of 8 hours and 56 minutes, and the suits have come a long way. During the Apollo 11 mission, Neil Armstrong couldn't walk on the moon properly, even though, technically, he was the first to walk on the moon. He actually did some bunny hops. But with the newer innovations and technologies, astronauts can walk and turn their hips in space. NASA plans on going back to the moon by 2024 and is preparing 2 new spacesuits with better technology and dexterity. It's called the Zemu, and it's based on the current design of what astronauts wear on the International Space Station. But the new designs and features will allow humans to live and work on the moon. A demonstration showed how flexible it is compared to the previous ones. You can twist and bend at the waist. The legwear section is better for walking on the moon's surface. Minor changes include no zippers or cables to keep out the dust.
That's one small step for man, one giant leap for mankind. Something Neil Armstrong, the first human that set foot on the surface of the moon, said. He was there with Buzz Aldrin, spending 2.5 hours on the lunar surface. Preparation for this project took a couple of years, and all the equipment the astronauts carried weighed over 170 pounds. It wasn't easy to land on the moon. There were lots of attempts in history that ended in failure. For example, astronauts in one of the Apollo programs had enough fuel to rocket people to the lunar surface in a mere 3 days. But they wanted to save on fuel, so it took them over a month to get there. There's no GPS to tell you where exactly to land. The spacecraft travels fast, and it has to slow down in a vacuum with not enough information. But since 1969, 12 people have already walked there. The moon is the only space object humans have visited so far. The rest have only been visited by robots. But all these people were just there for a short visit. NASA announced their program to work on a permanent presence on the moon. That would help scientific research and could be a good point to learn how to do the same on other missions, like the one on Mars. Imagine being the 13th person going to the moon. Scary silence, moon dust under your feet, and nothing but an endless black sky with stars all over you. But you have no time to admire the view. There are many issues you'd need to figure out before landing. First of all, our bodies are like machines that are adapted to conditions on Earth, like gravity, atmosphere, the air we breathe, and the food we eat. Our planet is where we function optimally. Our gravity is 6 times stronger than on the moon, which is, compared to our planet, almost a vacuum. Whatever you do, it wouldn't be smart to hold your breath in such conditions. The vacuum would pull the air from your body. Oxygen still present in your body would expand together with bodily fluids. They would push against the blood vessels and organ tissues. Your body, legs and arms, they would all lose their current shape and would bloat like a balloon to twice their normal size. If you stayed like that for a longer time, you wouldn't survive. But you wouldn't explode. Your skin is pretty elastic, and it would hold your body together. Liquids that are exposed to your body would evaporate. The surface of your eyes and skin, it would all boil. Saliva would literally boil on your tongue. But the blood would still be liquid. The walls of the vessels would protect it from boiling. No atmosphere, no oxygen either. The oxygen that's already in your lungs would quickly be gone, and you'd have nothing to breathe in. If your organs stopped getting oxygen, usually delivered to different parts of your body by blood, you'd pass out because your brain would shut down. It would happen in the first 15 seconds. That's how much time your body has to use the remaining oxygen in the blood to keep the brain functioning. Stay like that for a longer time, and bye-bye. No ozone layer, no strong magnetic field. The atmosphere of the moon is similar in density to those uppermost layers of the Earth's atmosphere, where we have the International Space Station. That means your body would be exposed to all those dangerous ionizing radiations from outer space we can't feel now, because layers surrounding Earth keep us safe. On Earth, our muscles and bones are tuned to resist gravitational force. Without gravity, we'd start losing muscles, and our bones would become weaker. It's like with the blobfish, a marine creature that looks like the saddest animal on Earth. This fish lives deep down in the ocean. When down there, it looks like most other fish, just slightly scarier. But when it's out in the fresh air, it becomes flat, and its entire body looks like some weird, sad pudding, all due to differences in pressure. The moon would make you look like a blobfish because of drastic changes in atmospheric pressure. There's no pressure that would hold your body together. While on Earth, a column of air presses an approximate mass of 15 to 20 tons on the entire surface of your body. We don't notice this because this air pillar presses the body equally from all sides. There's air inside your body too. Internal pressure is the same as the atmosphere. And on the lunar surface, there's no pressure from outside to back it up. It's also really cold up there. Temperature drastically changes from 250 degrees Fahrenheit during the day to negative 208 degrees Fahrenheit when it's night. A day on the moon lasts 29 Earth days. That means you'd be spending 14 and a half days in unbearable light, and the next 14 and a half days in scary cosmic darkness. Your body could eventually freeze solid if it's nighttime, the same as in other places in space. Depending on where exactly you're at, this would happen within 12 to 26 hours. Or, if you visited the moon during just one regular afternoon, you'd be burnt to a crisp. It's better to do what Apollo 11 did and come at dawn. The lunar surface isn't so cold yet, and it didn't have enough time to become extremely warm. Even if you survived all this, there are millions of meteor strikes every year. All those small particles of rock or dust that move pretty fast, or even orbiting debris from spacecraft or satellites. A human being wouldn't be able to survive in these conditions for more than 1 minute. To make it and stay a little bit longer on the moon, the first thing you'd have to take care of is getting protection from radiation. You'd need simulated atmospheric pressure similar to Earth's, and it has to be stable. You'd have to maintain the temperature of your environment, so your body doesn't freeze or burn out. Protection from space debris and cosmic dust, breathable oxygen. Oh yeah, you'd also need a communication system, water, food, and maybe some other things that you'd need to function normally. In 1982, NASA started using an extravehicular mobility unit, EMU, for their activities in outer space. The latest Artemis mission has spurred the development of a new generation of spacesuit. The XEMU is an amazing new generation suit that they came up with. It will probably be deployed within a couple of years. The suit has supplies of oxygen, both for breathing and for maintaining the pressure that holds your body together. One part, the liquid cooling garment of the suit, is form-fitting, which means it fits your body shape and has a system that receives cold water and then circulates it across the whole suit. That's how it maintains a temperature of around 70 degrees Fahrenheit. The water absorbs heat and then moves to the second part, the XPLSS of the suit. The Moon is our planet's only permanent natural satellite, the second densest satellite right after Jupiter's moon Io. It was formed in a collision known as the Big Whack. A huge Mars-sized space object hit our planet 4.6 billion years ago, shortly after we got the solar system and the sun. A cloud of vaporized rock was formed, made of a mix of particles from Earth and the other object. It went into orbit around our planet, cooled down, and turned into a ring of small solid bodies. They later got together, which is how the Moon was formed. The Moon has some cool things, like unusual water that moves and jumps around as its surface gets warmer and cooler throughout the day. The water is there until some of it melts, heats up, and ends in the Moon's atmosphere. The water then floats around and then gets to the area that's cool enough to go back to the surface. The Moon always shows us the same face. Its near side is marked by pretty big dark plains. There are still footsteps on the surface of the Moon because no one has been there since 1972, the year of the last Apollo. There are no geological activities there, like volcanoes and earthquakes. No rain or winds to erase them. Wouldn't you say it's time to make some new ones? We're traveling through space at the speed of light. The route from Earth to the Sun at that speed will take only 8 minutes, but it would take us about 35 years to reach our destination, which is, by the way, still very fast. By comparison, a conventional rocket would take about 600,000 years to make the journey. And here we are. It's a star system suspiciously very similar to our own. And our scientists suspect that life could exist here, just like on Earth. A red dwarf, 30% the size and weight of the Sun, lies at the heart of this star system. But these are the planets orbiting the star that interest us most. The first of these is L9859b. Its size is somewhere between Earth and Mars, but it's very light. It's only half the mass of Venus. But life is impossible on this rocky planet. It's too close to the star, and it's so hot, you'd burn a cake if you tried baking it on its surface. It's about 100 degrees higher than the maximum of your oven. The planet makes a complete circle around its host star in just 2 days, compared to 365 for Earth. And it gets 22 times more energy than we get from the Sun. So it's not only hot there, but there's a lot of dangerous radiation. The next planet is 2.8 million miles from its host star. That's 13 times closer than the distance from Mercury to the Sun. And it makes a complete revolution around the star in 3.7 days. But what's interesting is that the planet is 30% bigger than the Earth and twice as heavy. So it belongs to the class of super-Earth planets. Such planets can be rich in water ice, methane, and hydrogen. These are some of the elements that are necessary for life's existence. Many scientists believe that it's on such planets that extraterrestrial civilizations can live. But because of the great weight of the planet, it has a strong gravitational force. So these civilizations may not be able to fly into space because it's harder for them to get out of the gravitational trap of a super-Earth planet. However, life isn't possible here because the planet is still too close to the host star. And just like in our solar system, the 2 nearest planets are too hot. But the third planet looks more promising. L9859d. It's almost twice as heavy as the Earth and 50% bigger. Scientists have calculated that about 1/3 of its mass could be water. For comparison, the mass of all water on Earth is only 0.02%. The presence of water is the main condition for the emergence of life. But we can only guess where the water might be. It could be on the surface, but high temperatures can turn large oceans into giant clouds of steam. But water can also be contained in the groundwater below the surface. Well, we can't know that for sure yet. Let's move on to the next planet in the star system. This newly discovered planet is of the Super Venus class, L9859e. It's a rocky planet 3 times the size of Earth. The Super Venus class means that the planet is heavy enough to have an atmosphere, but the conditions there are more like a greenhouse. Different gases fill the atmosphere there. Star rays pass through them to the planet's surface, reflect off it, and rise upward. But the dense gases don't let them leave the atmosphere, so the planet gets hotter and hotter. This is the greenhouse effect that we try so hard to avoid on Earth. On top of that, The stellar wind carries water vapor and other elements from the upper layers of the atmosphere into outer space. Life cannot exist on such a planet, nor could it ever originate, just like on Earth's twin sister, Venus. So far, all the planets we've looked at are outside the habitable zone of the host star. That's the sweet spot, at a perfect distance from the star. Not too close, so that the planet isn't too hot and the water there doesn't evaporate instantly. And not too far away, so that the planet doesn't look like a cold desert. And planets B, C, D, and E are too close to the host star. But there's another hypothetical planet F in this star system, located right in this sweet spot. This super-Earth candidate is 2.5 times heavier than our home planet. So we have hopes that it's a rocky world, just like the other planets in this star system. The weight of planet F is enough to have a dense atmosphere, and the temperature on its surface should be suitable for water to exist there in liquid form. The planet makes a complete circle around its host star in 23 days, which literally means it's New Year every 3 weeks. It isn't very likely, though, that there's a civilization there that celebrates it. Indeed, the very existence of this planet is very doubtful, because we still have no direct evidence. All the other planets have been discovered by the transit method. That's when we point our telescopes directly at a star and watch its brightness change. When there's a slight drop in the star's brightness, that's when a planet has passed between us and the star, like this dot. We have a short period of time while the planet is in the background of the star to determine its size and speed. Sometimes we can observe such transits of Mercury and Venus on the solar disk. And there are at least 29 potentially habitable planets out there in distant space that can observe Earth in the same way. About 1,715 stars within a few hundred light years are perfectly located for it. Each star has planets around it, but only 29 of them are in the habitable zone. So there really could be life and an intelligent extraterrestrial civilization out there. If so, they could point their telescopes toward the sun and see a small dot pass across the solar disk. And they could have been making these observations for at least the last 5,000 years. So they could see how our civilization was born and how we evolved. Moreover, these planets are close enough to pick up our radio signals and even television broadcasts. But it works both ways. Radio signals travel through space at the speed of light. We mastered this technology about 100 years ago. So if there really is a civilization out there somewhere, we would pick up their signals too. But so far, it hasn't happened. So we have no proof of the existence of life on these planets. The discovery of a star system like L9859 is very important to us because we're always looking for life outside of our solar system. And super-Earth-class planets are even better suited for the origin of life than planet Earth itself. Such planets are sometimes called super-habitable. So some scientists think that Earth is a good place for life, but not the best. Super-habitable planets would have to be 30% larger than Earth and twice as heavy. This would create stronger gravity, which would make the atmosphere on the planet denser and with a higher concentration of oxygen. This in turn would raise the average temperature on the planet to a perfect 77 degrees Fahrenheit, so plants would thrive there. Also, stronger gravity makes the surface of the planet flatter, so there might be more oceans there than on Earth. This would make aquatic life much more diverse. The host star also plays a very important role. It should be smaller than the sun. The bigger the star, the more of its fuel it burns. This means that the lifespan of such stars is much shorter. For example, the lifespan of the sun is about 10 billion years, but a red dwarf can live up to 30 billion years. More time, more opportunity for the birth of life and evolution. So far, scientists have discovered 24 superabundant planets, but that still doesn't mean that there is life there for real. But some scientists believe that there are already at least 36 advanced civilizations in our galaxy, besides Earth. They've searched for similar worlds on the star map. First, we find stars that look like the sun among about 100 billion stars throughout the galaxy. Now we choose from them those that are rich in iron. Such stars burn at the perfect temperature and help the planets around them gain an iron core and become Earth-like. Now let's pick relatively young stars from this pile, because when they get older, They expand and either absorb the planets around them or burn them up. One last thing, let's find planets in this pile that are in the habitable zone of the star. And voila! 36 worlds may be inhabited by some unknown civilization. But we won't know for sure until we get in touch with them.